And so let me actually introduce what we're going to do for everyone who's joined up until this point. So hi, everyone. Merry Friday. Another day for a beautiful day for staying inside and coding. It's actually like 95 degrees, so it is quite good to stay inside today in New York City. But yeah, basically, we're going to talk about ZIO app architecture. And we built an example, a semi-real world example, that's going to motivate basically ZLayers, which are the tool that we use in ZIO, the recommended way of organizing your apps. In the last week, a couple of really cool resources came out from third parties, which is really cool when people who aren't even direct coworkers write about this stuff. That's exciting. So I believe Vlad, there it is. Devin ZIO, who I believe is Agile Steel. I believe his name is Vlad. I should probably confirm that. But this is called Agile Steel.
I believe that's right.
Okay, cool. Yeah. So he made a video on ZLayers and Z02, which I've liked. Yay.
Yeah, stuff is great.
Seems like a positive assessment, which is cool.
I also good energy. Yeah.
And also Adam Worski came out with a document as well, which is basically how to use ZLayers and Z02 and how to architect the ZIO applications. And we thought maybe we should also put something out there to summarize our views. Like there is no real way of there's a lot of subjectivity and sort of different ways of piecing these together, but we should at least sort of show what we tend to do and what works for us and make arguments for that. It is also worth saying, every time that these things come out, people have a lot of opinions on dependency injection and app architecture. And ZLayer in particular is sort of used for this problem of dependency injection. And there is this one thought, which is that dependency injection is basically like, just pass arguments to functions. What are you doing? Why is this necessary? This additional layer of complexity, it really doesn't need to exist. You're just adding complexity for some reason. Now, I get where that's coming from. We certainly don't want to add additional unnecessary complexity. We don't want to add new data types just because we can. Like that's something Adam in particular has been deleting.
We've been ruthlessly deleting them.
Yes, deleting as much as we can. We removed has, we removed Z-managed, trying to simplify and really express as much as we can in the simplest way. But we did keep ZLayer, and we did it because we think it's valuable. And we're going to try to motivate the reason why. There is a bit of a paradox in functional programming, in teaching of functional programming in general, where when you're teaching abstractions, like when we tend to actually, let me back up 1 second. ZIO likes to embrace the power of concretions. So we like to use concrete data types as much as possible. We tend to eschew things like type classes and tagless final. We really try to keep things as concrete and clear, because when something is what it is, you don't need to explain it. You don't need to say, oh, well, what's a monad? Okay, let's look at some concrete examples. It just is the concrete example. So you get intuitions for free. You can make assumptions about what you're doing. ZIO is sort of this, instead of being composed out of multiple monad transformers or other complicated functional, composable functional machinery, it's sort of a concretion that is scoped to the problem of building basically applications. You tend to want environment, you tend to want errors. You have result type. These are computations that might fail, that might require something that can have a result type. And instead of building that out of these orthogonal composable pieces, as elegant and mathematical as that composition might be, by making it concrete, by doing what John likes to call effect rotation, by sort of building this one superpowered effect type known as ZIO, you get a lot of niceties. You get a lot of helper methods that exist on the ZIO object. You can make a lot of nice assumptions. It is technically a little hard-coded, but it tends to be, it's actually hard-coded to the domain that you're using 99.99% of the time, which ends up being a nice thing in my argument, in my experience. Okay, so why ZLayer? Let's try to motivate that and show off basically how to use it, what problem it solves, and try to do so in a non-trivial way. Oh yes, what I was just talking about was the difficulty of teaching these functional abstractions is that because they're abstract, you need to sort of show you need to reach a certain threshold of complexity before the additional overhead of the abstraction starts to pay for itself. So sort of in a one-on-one head-to-head combat between something concrete and something super abstract, the concrete thing will usually win in a simple example, right? Like if you just think of some basic Java code that's side effecting, and maybe, you know, it might blow up, but who cares? Use exceptions, let it throw. If it's a 1-line file or like a 10-line file, is it really worth learning all about effect systems and everything else? You know, there's an argument there. If everyone wrote really simple applications that were only 10 lines long, there's probably not a good argument for any sort of abstraction at all. Just understand the thing fully in your head, load it all into your head, and just deal with the consequences. But of course, our programs are not 10 lines long. They get big, and they only get bigger over time, and they only get more complex over time. So functional programming and effect systems in particular, the further and further you go, the more complex your app becomes, the more and more they end up paying for themselves. At least that's kind of been my experience. Many subjective opinions on this, but I feel like, yes, once it scales linearly with the complexity of your program versus sort of getting increasingly confusing, especially as you deal with concurrency. And that's kind of the problem with teaching ZLayer. A lot of people say, so dependency injection is just simple, right? Just pass arguments to functions. What's the big problem? So as a simple example of this, let's say we have some kind of user service that depends on like a database, a logger, and analytics, right? So we have some users case class here that has 3 quote unquote dependencies. And in order to build this instance of users, we need to provide it a data source, an analytics, and a logger. Well, if you go by the simple sort of just pass arguments to functions, stupid approach, that's quite easy in the simple case, right? All you have to do is basically instantiate a logger, instantiate a database, instantiate an analytics, and then construct the users. And in a simple case, that is totally fine advice. It's not worth any sort of greater abstraction. Just use basic Scala constructs, there's no problem. But what ends up happening in non-trivial applications, and this application is still relatively trivial, is that you have a lot of dependencies and a lot of different services. And you sort of, the main function, there's this sort of notorious main object. And in there, in large applications, you will have hundreds and hundreds of lines of code that build and basically wire together manually your entire application. And that can get very confusing. This is still quite simple, but we can see sort of certain things occurring here that might be a little confusing. For instance, the second one of your dependencies needs to have some kind of acquisition and release of resources. Like maybe if we want to create a data source that is a connection pool. So we want to acquire effectively all of these database connections and release them when we're done. Or maybe if we have a file logger and we need to open up the handle to a file or some, you know, third-party web-based logging API, we need to open a connection and validate our credentials and all that sort of things. We need to start acquiring resources. So we need to start doing things effectively. And things are going to start getting stacked. And if we're not careful, we might not build our application necessarily as quickly as we can. Because things might be able to be acquired and released in parallel. But if we're doing things manually, and you can imagine if 20 people if you have a large development team, and they're all working on this application, what is the sort of the confluence of all their changes? Where are all the Git commits going to intersect? And that's probably going to be in the main, right? If you change anything that has to do with what services depend on what other services, if you're building everything in this sort of big main file, the main file technique, which even the detractors of ZLayers say, okay, yeah, maybe the mains can get a little complicated, but at least it's all, you know, there and you can see how it's working. These things get huge and Git conflicts end up happening, and it's really hard to maintain a clean looking structure. Like this was only me coding it, and it's relatively simple, and I've put in some effort to make it slightly readable here. But if you are just changing things at the same time as lots of other developers, and there are lots of Git conflicts, it's really difficult to there's a high level of churn, I guess, on these main files is what I'm trying to say. And it quickly deteriorates. And once it starts to deteriorate, it really is only going to compound over time. And you're going to get this spaghetti kind of main file, which we're going to try to take a look, because this is one of the big motivators. Avoiding this is one of the big motivators of ZLayer, and you get other benefits as well. But in my experience, applications with lots of developers that I've worked on in the past, where we use ZLayers to wire our applications together, you basically don't have any of those problems. Your main file is just kind of a list of these modular layered definitions, or just layers. You're selecting layers that you've already defined, and these will be wired together automatically for you. And if you add complicated dependencies and interrelated dependencies, that's not really something you have to deal with as a user. Even if there is acquire and release logic, the ZLayer wiring capabilities will figure out the ideal optimal wiring strategy and just do that for you behind the scenes. And it's really something that you don't need to customize. The structure of your final application construction is going to really be almost deterministic based on the structure of your services. So basically the way we can view it is that if you need a user's, its dependencies, its inputs are just going to be the parameters to this user's case class here. So if you're going to get a user's given a logger, an analytics, and a data source. And then you can sort of build this tree just by walking the graph of the dependencies. So if we use analytics live, well, this analytics service needs a logger. So we're sort of building up this application dependency tree. And those exist whether or not you use ZLayers or you just construct things manually. And so yeah, analytics actually depends on logger as well. So I would add this to my little tree here. Oops. And so on and so forth. Okay, so that's kind of the beginnings. This is sort of the non-ZLayerified version of the problem. We're also using zmanaged, which I just mentioned Adam removed, but this is to make it sort of more similar to what you might have seen in the past and what sort of other ecosystems might do that have data types like managed and that do not have data types like ZLayer. And hopefully we can make this a little more complex. I think it's really important to demonstrate what it's like to modify and refactor and work with this kind of code, because that is, you can make something that's beautifully factored, and as long as it never changes, you'll be okay. But the thing is that, as I mentioned before, this is sort of the cynosure, to use another $2 SAT word. This is the nexus of all churn in your code base. Everyone's eyes are on this file, and they're all changing it in every single non-trivial PR that changes anything to do with the order of dependencies. And if you take something that was previously pure and you make it say its instantiation acquire and release resources, you're going to have to do a shuffle. So let's just start with that. Let's say, okay, user's live. Let me take one step back and describe what the heck this application is doing. I think that's probably a good thing to do. What are we doing here? So we've made a very basic, trivial Meetup application, which is just a domain that I've probably used before, and others I definitely have used in other symposiums before. So we're not even thinking about the domain much. It's kind of like meetup.com. You have users, you have events, and you also have RSVPs, so users can RSVP to events. We're going to add some more complexity to it, but that's kind of our domain. Let me make sure this thing is running. So we are running it currently, and it's a server. So I'm going to go to Postman, and we have a few things here. I can get all of our users. So I have Adam and myself. I can get all of our events, which is just Idiomatic ZIO app architecture, the current event you're all at. And then I can also get RSVPs for an event. So for the event, for this event, there's one RSVP, which I believe is F9. That's me. And if I wanted to add Adam to the event, I can go over to create RSVP, and I can also add Adam's user ID here, save it, and then, oop, something blew up. I might have not copied Adam's thing correctly, or I've done something else wrong. That's no problem. User ID, did I do that right? Server error, duplicate key violation. Oh no. Oh, I've done something wrong with my database tables. Okay, let's ignore that. I hacked together a database very quickly. Were you going to say something, Adam? I'm sorry. I'm kind of rambling. No,
you're doing great.
Okay. So that's basically what the app is. We have users. We have here's the database tables. We have events. We have RSVPs, and we have users. Maybe I can modify something here. Did I make it so that only one is the prime? Okay. I made it so that just the user ID is the primary key. So let me also make this a primary. No, they're both primary keys. Oh, okay. There we go. So if they're both primary keys, now it's a composite primary key. Now I should be able to create an RSVP, hopefully. There we go. Yeah. So now I have two RSVPs for the event. Both Adam and myself are indeed attending Idiomatic ZIO app architecture. Okay. It's kind of hard to get a sense of this just by looking at, Postman JSON output, but hopefully it's simple enough. It's just kind of a basic cruddy model where we can create, read, and update users, events, and RSVPs. We're going to make it more complex over time, but that's what we have now. Okay. So let's go back to our main. So what is the structure of this? Well, it's the top of our tree is this Meetup server. And this tree kind of gets inverted when you do things these way, like when you do things in this sort of manual instantiation style, because the top of your application is going to be the most nested, because it needs you to first instantiate everything it depends on. So the top of the tree is sort of at the rightmost level of indentation here. So our Meetup server is the entry point to our application, and we start our application by calling start on the Meetup server. So the Meetup server basically needs a user service, an event service, an RSVP service, and a logger. And it will use ZIO HTTP here to just define some routes. So the user's routes for creating, getting users, and same with events, and same with RSVPs. We're not going to quite get into this. How this works, there have been other sessions on ZIO HTTP. We'll do more in the future, I'm sure. But this is just a basic server. And we call start on port 8080 down here. Okay, so that's kind of the entry point to our app. Yep.
Yeah, and I think the thing to emphasize here is if you go up this so far, we're using ZIO, but we're not doing anything ZLayer or even ZIO architecture specific. This is constructor-based dependency injection, right? This is just, we have this interface, it has these things it uses, we make them constructor parameters, they're right there. There's nothing kind of special about this so far.
Yep, exactly. But you can think of this as sort of defining a little dependency graph by saying that a Meetup server needs, users and events and RSVPs and logger, and then this will give you a Meetup server, right? And depending on which instance of users or events you decide to use. So if I jump down into users, okay, users live needs data source, analytics, and logger. So we're going to go and say, all right, well, we need a users. Let's use users live, which needs data source and analytics and logger. And so this is kind of like, nodes in a graph right here, the dependencies of this node and so forth, so on and so forth. And basically to figure out manually how to build your final application, you have to walk the graph. You have to traverse the graph manually by hand and keep that graph traversal up to date. So we needed all of these inputs. So we're going to make sure that we sort of construct them. And these have their own inputs. So we're going to have to make sure that we construct their inputs. Of course, some of their inputs are resourceful or require effects to construct. So for instance, Analytics Live, we have this constructor, this managed constructor that will take a logger and then create a managed version of analytics. Now, this is just a demo, but one could imagine that what this actually would do is register, connect to some third-party streaming API or something that it's going to pipe analytics over. So it'll create some socket connection to some streaming API and some analytics a website, third-party analytics service. Who knows? Currently, we have this little fake make managed utility that will just sort of simulate that by saying that it's starting the service at the beginning and then shutting down the service at the end. So you can imagine more complicated behavior that it would actually perform here, but we're just trying to we're just showing off the architecture, not actually how to connect to third-party services. Okay, so this is just a little pretend, but to create this Analytics Live, we need a logger. And then this gets us back a managed. So in order to actually access the analytics now, we have to call use on our zmanage, which will give us access to the analytics in this scope. Just a quick question. Where are the recordings for the previous sessions located? And that is, if you go to our Zymposium repo, I added a link to the playlist in the About section. So just search for Ziverge Tech Zymposium, and you'll find that there.
Yeah, and also if you go on the Discord, I'll just paste it there so everyone has it.
Yep. And let me post another Discord link because so many people are here. Discord.
Yeah, that's a great idea.
I think, did that work? There we go. Discord. So yeah, definitely join. Oh, host and panelist. I'm only pasting it to you, Adam. So there it is to everyone, and then we'll have more information there. Cool. Good question. Okay. So as we can see, it is quite simple just to do, dependency injection via just calling passing arguments to functions udolt that name, which is comes from a good place. But as things get more complicated, and as some of these services require resourceful instantiation, and the strange thing about this is that, well, the logger itself also requires resourceful instantiation. So we create two other managed services here. So this one is going to be a zmanage that will get us back a file logger as well as a data source. So this creates the connection pool to our database, and this opens up a handle on a file to log our messages to. But because analytics depends on logger, we need to call use twice in this nested form, which is okay, fine. It doesn't look so bad. It is representing the structure of our application. But the second we have to change things, imagine that logger used to be pure and in here, but now we decided to use a file logger instead of a console logger. Now we have to lift that file logger to the outside, zip it with some other with the other managed at that level, or nest it, or do something else. We have to sort of change this in a non-trivial way potentially. And as I mentioned, if multiple people are working on this application and they have to do that in parallel, you're going to get a lot of conflicts in this file, and it's just going to end up pretty messy and difficult to maintain. The more a file churns, the more difficult it is to keep nice. That's why modularity is nice. That's why solid principles are good. Okay, so I have this little some variants just to sort of show what that process might look like on these different services. So users live, instead of just creating it like this, which we could do right now, there really isn't a need for resourceful acquisition, but let's pretend there were for some reason. Well, now this gets us back, instead of just a users live, it gets us a users inside of a zmanaged. So now we're going to have to do that same thing and call use on this, use, get the users, and so on and so forth. And then just add another layer of nesting. Same with it's managed.use events. And there we go. We can keep nesting them. Of course, we can realize that, wait a second, these have no sort of intermediate dependencies. So right now we could, if we wanted to, zip them together. And of course, what we really probably want to do is zip them together in parallel, which we haven't done even above. So this is all sort of manual things that you have to worry about to make sure that your app starts up as quickly as it can. And yeah, so you have to make sort of these non-trivial, sort of boilerplatey transformations to your code. And let me just quickly show what this looks like now. So now when we start this, it's starting analytics and then events live, and oops, I have copy pasted. So this should say users live. So let me have that restart. So it's starting analytics live, then users live, then events live. And if we wanted to, I could make this whole thing timeout after 1 second. So we could just see the fact that it will acquire at the beginning, and then once it times out, it will release everything in reverse order. So started all three of these, and then it's going to shut down events live, then users live, and then analytics live. So it shuts them down in reverse order. That's kind of how these zmanageds work. Zmanageds work. A bit of a tongue twister. Okay. So hopefully that gives you a little peek into the awkwardness of such a construct. I'm going to do one more thing here as well, which is show what happens when we need to add dependencies to this kind of thing. So I don't think I have, do I have a managed for RSVPs live? No, I don't. That's okay. So for, let's say, actually, no, I do want to do this for RSVPs live. So let me go down here. I will make a companion object, and I will do def managed, and I will do the same thing as I did before. What is it? What does it need? It needs data source and logger, and then I have this little utils file that just says utils.make managed RSVPs live, and then RSVPs live. Just need to build this here. There we go. Okay, so now we have a managed instance of that. Perfect. So I will also go back to my main and say, okay, RSVPs live were also managed. So I'll call use RSVPs. Good, good. Okay, so now everything is inside of a managed, and oops, I've blown something up. A legal start of a simple expression, RSVPs. What have I done? Oh, I've deleted the code I just wrote. Okay. Don't know at what point I did that. Okay, there we go. So now it's starting up everything. Good. Good, good. So we have this very nested thing, which we could refactor, but this is the difficulty of making these transformations. It can be difficult to keep this optimal. We can imagine that all three of these refactorings were done by 3 different people at the same time. And now we have to resolve all these Git conflicts, and not every developer necessarily knew how to organize this optimally. And even if you did, it would be difficult to resolve all those Git conflicts and track this stuff. I mean, that's not a fabrication. I've experienced that multiple times. I assume others out there have as well. Okay. And it's never the most fun programming task. Okay, so let's add something to one of these. For RSVPs live, let's add this thing that we have called a notification service. So notifications basically is just a service that has a method called notify owner, and this will notify the owner of the event, saying that, hey, this new person has joined your event. So notifications live is this implementation here that takes events, users, and an email service. Email service just has a message that just lets you send a message to an email address. It's not fully type safe. In the real world, Adam and I have professed our love for case classes that, new types and case classes, and so on and so forth. But forgetting that, it's just a simple email service that sends a message to a string. Okay, and its implementation will get the event, get the attendee, get the owner, and then send an email to the owner saying that attendee's email has RSVP'd for the event's name. So that's the implementation of notifications live. And so far, we're not using ZLayers at all. This is just nice, as Adam mentioned, constructor-based service definition. It's just a OO pattern that's great to have. And it's why I'm happy that Scala is this multi-paradigm language. It's a very useful thing to define services. Okay, so now what's the pattern when we want to say add notifications to our RSVP service? So whenever a user RSVPs to an event, that's when we want to notify the owner. So it's pretty simple in either way, right? All we have to do is come up here and say notifications. So we add this as a quote unquote dependency to our service just by adding it as a parameter. And then down here inside of create, once we've created the RSVP, we'll call notifications, notify owner, and pass in the RSVP. So it's just a nice boundary between abstractions. We just delegate and call the notify owner message on notifications. So that's sweet. They're not coupled in any way. We're just hoping that some implementation of this exists that does the right thing. And we could test this by passing in a test implementation of notifications that maybe just has some in-memory ref that we'll check. Or we can use the real thing in production. Super great. All right. Of course, there are a couple of other changes we need to make because we have this, because we're passing in, because we're using functions, functions cannot automatically resolve themselves. So we sort of have to update them manually, which is not the end of the world, but let's go ahead and do that. So I need to update this function here, add a new argument, and now we'll have that there. And then back when we're calling this, we need to add notifications, right? Notifications. And this is kind of where that pain starts to occur, where we don't have a notifications service yet. So we're going to have to insert one into this hierarchy somewhere. And where do we do this? And how and at what level do we do this? That's up to us to figure out, which is a bit of a bummer because it is kind of almost an algorithmic deterministic process. What we're going to do manually as humans, since we don't have a macro or something to help us, is that we're just going to look at the implementation we want and we're going to see what it needs. Okay, so we need events, users, and an email service. Okay, great. So now I can, this is the process. Haven't done this before, so this is going to be real time. So we need events and users. So great. So I think we want to create that here because we need to instantiate it at a point where we have events and users. So I'll say notifications live, and we'll pass in events and users, and then we need some kind of email service, which we do not have. And I guess because currently this is not managed in any way, I don't believe, I will do this. So now we need email service. So maybe I could say email service equals what? Email service live, there we go. And we need a logger, which we already have. So, okay, cool. Now that wasn't the end of the world because both of these were just pure services. If we in the future wanted to change this to be managed, in fact, I have it managed here, then we're going to have to do that whole rigmarole again and change it around. Flat map, notifications, and get increasingly nested, you know, callback hell, notifications, and layer that in there. And oops, I've screwed something up. Oh, not flat map, just use. Okay, great. And as you can see, this is still a very trivial application, but we're already like 17 layers of tabs in here. And it's quite difficult to read. Yes, it is explicit to some degree, but it's also really boilerplatey and deterministic. And really, the only thing we can do here is screw things up. When the only thing you as a user can do is screw things up, that's a great opportunity to see maybe there's some higher level of abstraction we can use. Maybe that's actually a situation where macros really pay for themselves. For instance, why do we use macros for instance, let me go to RSVP here. We have an implicit JSON codec, right? We use macros all the time. We have no problems using macros for generating JSON encoders and decoders for case classes. And the reason why is because this is just pure boilerplate. We can only mistype something. We can only accidentally ask for event ID instead of event ID, or parse the wrong type and run into issues later. It should be totally deterministic, and we can offload all of that burden onto the compiler. And this is kind of another situation. This looks really horrible. And the good news is none of this is necessary at all. And we can get other benefits from it as well. For instance, right now, things are not done massively as parallel, as efficiently as they could, because there are no dependencies between events and analytics and users. And so we could zip them all together in parallel. So acquire and release them all in parallel instead of having this unnecessary sequentiality brought to us by the use. And also, now that we're getting sort of these multiple layers of nested, pure and managed effects, it's becoming increasingly difficult to refactor and to reason about, I would argue. Okay, so that's kind of that example. So now let's change it. Let's see what it's like to make that process, to have that thing use ZLayers. How would we use ZLayers? Okay. So let me say new program here, new program. And let me say, let's do this. So I'm going to say ZIO.service, and I'm going to get ourselves the, what is it called? The Meetup server. Server. And then I will say server.start. Good. And I guess I could have just done service with ZIO and done start like that as well. That would also work in this case. That's literally the definition of that. So what is this? This is a program that requires a Meetup server and will return nothing because this runs forever. Ideally, it'll run until it throws or is interrupted or something. Okay, so let us instead now use our new program. And we get this friendly error. So this is obviously way simpler than what we had previously, right? Duh. But it really is the actual logic that we want to express, which is saying that we have a Meetup server and we want to call the start method on it. That is really what is our application's main entry point. But of course, there are all these decisions to be made about how we want to construct our application and provide its dependencies. Okay. So here we get this nice new Z02 error that happens at compile time. So I really could just inline this and it should give me the same error, but I'll keep it separated for now. New program. And it says your effect requires a service that is not in the environment. Please provide a layer for the following type: Meetup server. Call your effects provide method with the layers you need. You can read more about layers and providing services here. So yeah, we could follow that, but don't worry, we know that. So we'll show you what to do. So the first thing to do is to call your effects provide method. So the second I do that, I can just call provide. And now it's basically going to give me a sort of less verbose version of the same error message, which says, please provide a layer for the following type, Meetup server. So now we need to start constructing layers, which is, yes, this additional bit of code that we need to write, but it's quite deterministic in the simple cases, and it scales out to your entire application. And what it allows you to do is achieve, as we'll see, modularity. So right here we have coupled in this one big spaghetti method, and you can work your hardest to prevent this spaghetti from generating, but this is sort of this spontaneously manifesting spaghetti. These high churn areas of code tend to, just spaghetti materializes out of thin air and starts wrapping around everything. It just happens. It's unfortunate. Whereas ZLayers are sort of these Lego pieces that are just simple ways of describing each dependency's inputs and outputs. So if I go back to, I had a little comment here a while ago, basically each of these are going to be their own little layer. So each of these nodes in your dependency graph that says, okay, these dependencies are acquired by this, this service, each of these is going to become its own layer. And it's going to be co-located in either the implementation or the sort of the traits companion object. For now, we'll just put them arbitrarily in one of those two places. So everything is modular and defines basically the rules for constructing just that piece of data. Okay. So I'm going to make a companion object for our Meetup server, and we'll start here because that's what sort of our little error message is telling us. We need a layer for Meetup server. So how do we do it in these simple cases? So this is a simple case where the Meetup server currently does not require any acquisition or release of resources. We could rework it if we wanted to do that, but it's quite simple. So here's our companion object. Okay. And I'm going to just say val layer. And I'm going to say ZLayer.from function. This is probably what you're going to be using most of the time in these simple cases. And I'm just going to say Meetup server dot, I think I do underscore if I wanted to do dot apply. And what it's going to do is it's going to take the constructor that's given to us for free by having a case class. That's kind of why we're using case classes here. And it's going to translate that into a layer. And what that is going to look like is this. So if we look at this, it looks very similar to what we wrote above, which is saying the following. It's saying these are the dependencies. The first parameter are the dependencies. The second is how it can fail, and this cannot fail. And the final argument here is what you're getting out of this layer. And ZIO uses intersection types to represent sort of the and words. So this needs users and events and RSVPs and logger, and it will get you a Meetup server. We actually export and as an alias for with from ZIO. Yay. So we could use that too if we wanted to. But that seems to be confusing IntelliJ right now, so I'm not going to. Great. So let's use this layer. Let's use Meetup server.layer. So main. And let's provide Meetup server.layer. Okay, and let's take a look at what our new error message is. So now you get this error message. ZLayer error. Please provide layers for the following 4 types. So instead of having to manually traverse this graph, this little provide macro is doing it for us and giving us friendly error messages, which is a nice thing to have. So now we need to basically pick and choose, reach into our box of implementations, which layer do we want for each of these? Much of the time, there will either be just a live implementation and just a test implementation, but sometimes like with logger, you'll have, oh, do I want a file logger or an API logger? And you can mix and match these layers as you please. And they each come with their own dependencies. So we're slowly traversing and building out this dependency graph. And depending on what implementation we choose, it's going to add maybe more environmental dependencies. Okay, so let's start by going through this. So now I want to say user, yep.
Well, just one thing I think is good to note here is I think people have this idea that because you put one of your dependencies in the environment type, that you have this like tight coupling that like your like dependencies say like everything you need, and you have this like hard coding. But I think what you're seeing here is the opposite of this, of like this thing is just saying, I need a Meetup service. I need this like Meetup server that's kind of the next layer in the onion. but I don't know anything about how this Meetup server gets created. Like in this case, we're using this particular one that needs the users and the events and the RSVPs and logger, but there could be some other way of creating a Meetup service that doesn't need those things. And we'll see the same thing for each of those. So it actually helps you separate out these different things.
Yes, if I wanted to, I could just make a new Meetup server. The only, actually, wait, Meetup server is a case class currently. So I don't even have a trait here because
okay, so we do that.
Have one implementation, but yes, I could just make a different. If this were a trait, I could make a different one that just simply did nothing, because the only exposed method really here is something that never returns. So we could really do anything we wanted to. But this particular layer has these particular dependencies. Okay, so let's keep fleshing this out and see what happens. So Meetup server layers. Now we need a users layer. So I'll say users and users live, and I'll put a layer in here. So let's go to users live. Okay, so I will say val live, and I can say ZLayer.from function users.apply. Oh, sorry, users live.apply underscore. Let's see what we get there. And now this is going to get us a layer that needs data source, analytics, and logger, which is great. Now, of course, we did have this this bit of acquisition and release code, and we can get back to this in a moment and show how to translate that. It's not going to be really any much of a problem. But for now, we'll just start with this, and we'll see how we can add that kind of thing in a moment. Okay. So let's go back to our main. It's going to be a bit of boilerplate just at the beginning. So users, oh, let me make that .layer. So users live.layer. And now we need a whole bunch of other stuff. And our error message has expanded, right? Because we need, for users live, we need data source, analytics, logger, and we still need events, RSVPs, and logger for layer. So let's just, for the Meetup service. So let's just go through and say RSVPs live.layer. And what is it? Events live.layer. And I'll just go through and keep making these values here. So same exact thing, ZLayer.from function, RSVPs live.apply. It's going to get us that. RSVPs. Cool. Lovely. And then what else do we need? We also needed a main events live. It's a little unfortunate, but I wanted to make it non-trivial, so we got to all enjoy this process. Events live, .apply, .underscore. Sweet. We should probably add to our ZIO plugin something that does this automatically for us in the future. Cool. So there's our layer for that. Main events live layer. Perfect. So let's take a look at our new error message. Nice. Oops. So yeah, now we've, okay, Meetup service needs a logger, and then all of these now need their dependencies, which actually all happen to be almost the same. So data source, analytics, logger, etc. Okay. Sweet. And they're all numbered so that these all need the same thing. It's actually a bit weird. I don't know why I did that, because it looks like it's in a different ordering. But anyway, Meetup logger, Meetup logger, Meetup logger, Meetup logger. So there are 4 different layers that are required by all of these. Logger, data source, analytics, and then the 4th and last one is notifications. So we need 4 more layers to create here, which is no problem. For the data source, I already have one defined in our Quill context. So this is going to connect. This is a resourceful thing that's going to create a connection pool and release it at the end of our application. So I could save that again, and we'll see that everything has just been cut down because that same data source layer has been provided to everything. Okay, and then I'm going to go and say logger, file logger dot layer. So let's go and do that. Create value layer. And in this case, actually, maybe it would be nice to have something that is effectful, because this actually is effectful. I'm using zmanaged here to create a file writer and close it when it's done, and then basically emit all our logs to this one file, which we haven't looked at yet, but we should do that. Okay, so for here, I could just say, I think ZLayer from managed. Nope, not quite. function 1, ZLayer. Let me do things the other way because we don't really have managed anymore. Anyway, so let me see. I will say, is there from managed? There is from managed, and then I need to just put a managed here. Oh, okay. ZLayer. So I'll say def layer given a path. I'll just do this for now. Make. There we go. All right. We can clean this up later, but just to show, just to connect everything at first. So file logger.layer, and then our path is going to be path.of what it was before. Cool. So now if we go back, we need less. What do we need? Sorry, the quill is printing all my SQL queries. So now we just need analytics and notifications. Fine. So analytics.live.layer, almost there. And I will do the same thing of ZLayer dot from function analytics live dot apply the underscore, and there we go. And you don't need to widen this to be just analytics because it'll work either way, but I'm just going to do that. Okay, and then main. All right, and now we just need one last thing. We just need notifications. So notifications dot live dot layer, create value layer equals ZLayer. Oh, it knows it. Oh, because I'm in the same file as before. Yay, that was a good idea. I did not put this into its own file yet. Okay. And now, where are we? Oh, yes, because this needs an email service. Email service live.layer. Because, yeah, notifications layer, because we selected this implementation that needs an email service, we now get this added. So we're not done yet. So we kind of slowly build out our bridge, build out our tree node by node until we're done. Okay, so create value layer. Okay, ZLayer from function email service live.apply. There we go. Type. Cool. Don't even need to give these types, but just for the sake of it, I will. Okay. And now our application is starting. Yay. Okay, and hopefully everything still works. Let's go to Postman. There it is. Okay, all events, everything is still working. Yay. Events for RCP. So, you know, interesting trade-offs. Mostly these are just boilerplate for now. However, some of them are not. For instance, our data source layer and also our, I believe our, where's their file logger layer, both involve acquisition and release of resources. But we don't need to do anything special. We just keep providing the layers. ZLayer will deal with the acquisition and release of resources by itself. And basically what we're going to get back is something that will do essentially something like this, except it will be as maximally parallelizable as possible. So we're going to acquire in parallel at each stage as many resources, as many services rather, as we can. And basically, so what you get is that each of these layers is really just a single little modular piece that describes how to construct just that node from its inputs, its abstract inputs to a concrete, potentially, output. So it's just, everything is due to the way that it's constructed, perfectly modular, just a little Lego piece of your dependency graph. And if we want to look at this, there's some fun things we could do. There's a ZLayer.debug .tree method that we can add in here. And what this is going to do is it's going to print out a tree of our applications, wiring graph. Yay. So this is kind of the thing that we had up here at the top. So Meetup server there depends on user service live, which depends on data source analytics. Analytics depends on a file logger, and so on and so forth. Events live depends on Quill and analytics and file logger, and so on and so forth. RSVPs depends on a notifications layer, which itself depends on events, which depends on analytics, etc. So you see this entire graph that's generated for us. There's also, if that's a little hard to read, which maybe it is, there's another sillier one called Mermaid, which will give us this huge link, which I hope will work. And it will, oh, oh no, the URL failed. Maybe I'm too complicated here. I haven't tried it on such a large link before. So that's a bug report for myself. Why? Please code. Yeah, okay. Oh, that's funny. They have a little flow chart for when you pass malformed JSON.
That's funny.
So that's hilarious. But I did screw up that thing, so that's sad. To do open PR. Yay. Great, but nonetheless, I think you can sort of get the idea of what this is doing for us. And the real nice thing is how you have to make changes once you do have layers. So yes, it was a bit of work because we needed to create all of these layer definitions, but generally you would be doing this as you went along. And what we do not have to do is slot in or shift around a huge spaghetti blob of code. When you add a new dependency, you just add a new layer. And one of the very cool things is if you already have that dependency in your provided here, you have to do nothing. You just need to add it to your service itself. You do not need to update the main function at all. The only time you need to update your main method is when you add a totally new layer for the first time. From then on, it will just sort of reanalyze the dependency graph and provide that layer to something else. So let's see what does not have something. So I believe, yes, notifications live does not include analytics now. What if we wanted to make that happen? What should we do? So I will go and add analytics to our, not analytics live, just analytics to our RSVPs live. We're not even going to use it, but we'll just add it as a dependency here. Okay, so what happens? Well, the first thing we need to do is, well, we have this thing, all we need to do is just regenerate the type. And that's it. That's done. Just regenerate a type. If we didn't have a type here, it would just, we wouldn't need to regenerate anything. So that's kind of interesting. For here, though, we need to actually do something because we're not using the environment. So I'm going to say, all right, let's add, what did I add again? Analytics. Analytics. Where does that go in here? Analytics. So you got to figure out where to slot things in. Oh, order matters. What a bummer. Did I even do that right? Seems sad. Let's see, what else is sad? Unspecified parameter for logger. Oh, that's okay. So that, no, it's happy there, main. So now here we need to add analytics where, no, wrong place. Oh, I put that at the front here, analytics. And luckily that all works. But here we have to do nothing. Here, there's nothing to do because we already had an analytics supplied for us. So the only difference is that now analytics is going to be provided to our whatever service that was, notification service. So now notification service, so look at the pink for its dependencies or red for its dependencies, will now have analytics in it. Yay. So RSVPs now takes analytics. So that's nice. Yippee. So all we really had to do was change our our notifications layer. Oh, was that right? Notifications? Did we add it to notifications? No, I did not. Anyway, so that's kind of nice. So let me delete the old version so we could just see what that experience is like. So I'm going to delete the program so we don't need to update anything there. And we're going to just add to our notifications live analytics, and I'll comment out managed as well. So if we didn't have a definition here, let's see if that works. It does. Okay, everything's compiling. If we want to add to our notification service analytics, all we have to do is add it and use it internally if we want to. You know, analytics dot emit cool beans. I'm sorry for making that reference. And it works. This is just a logging message. Everything still works. And that's kind of what ends up being the experience in a real world code base of sort of any complexity. In fact, the more complex your app gets, the more and more this tends to pay off. Like Adam and I had used this on a team with like 40 engineers working simultaneously in this like huge sprint where everyone was working on the same application. And because we set it up to work with ZIO at the beginning and with ZLayers, we really didn't even get called in to do any layer debugging or anything. People just added their layers. They've copied the pattern. They added layers when they made new services. They didn't have to wire or integrate their changes. They really could just work in their little module. Everyone could work in their own module and not step on each other's toes, which enabled really, really, really quick iteration on this thing that would have otherwise been like, oh my, I don't even want to imagine what this style of instantiation would have looked like for this application, because it had hundreds of services in it, and it was so painful. And so it's kind of the experience that I wanted to, I think, talk about today. And that last one is really what ends up happening most of the time. And that's kind of the thing that's difficult to show off in toy examples, which is why this took an hour and was not such a toy example. Because that is really where it pays off. It pays off in non-trivial applications. Of course, I hope there's enough sugar and enough niceness of having these like nice error messages that makes it worthwhile in even small applications. I use it when I make anything, really, just because I like not thinking about this stuff and not having to scale it or change it around. I can just make my layers. Maybe we'll follow up next week with some more advanced patterns and techniques, but this is kind of the basic way of getting it to work. I'd like to go into sort of how to add those acquire release features into layers. I've talked about that in my conference talk on ZIO app architecture from ZIO World, so you can look that up on the Ziverge channel as well. But yeah, I think this is the thing I didn't get to really show off in that talk, which is just how, like in a non-trivial app, the experience compares, especially to what is the sort of default experience, which is sometimes recommended. And if you still like this way, that's to each their own. But I hope I've at least shown a bit of a motivator. We've shown why this can be useful in a large application, given a taste at least. Cool beans indeed. Okay, cool. Any last questions? I actually have to leave a little earlier today.
I think there were lots of questions. I was kind of hitting them in real time as we were going, so I can definitely, I'll do a little bit of follow-up after we get off here.
Okay, so yeah, if anyone is curious, just stick around in the Discord. But yeah, if there's any really juicy, interesting things that we touch on, maybe we can do a follow-up next week. I think there's a lot we can talk on. So yeah, if anyone has any thoughts of things that we want us to dive into more, we'll follow up next week. But thanks everyone for coming. That was super fun.
Bye.
Bye, Adam.